Okay, sweet. Okay, so I'm just going to show you the demo. Remember we talked about electrolytic cells or electrolysis and how you can actually decompose substances? Okay, so what I have here in this U-shaped tube is potassium iodide in water. So potassium iodide, it's potassium combined with iodine. It's already mixed together into a compound. So they're bound together. It's an ionic compound, so there's been an electron transfer, and there's two charges holding it together. Water, H2O, it's a covalent compound, so there's electron sharing going on, and it's attached to the bond. Okay, so I'm also going to put this stuff in. It's called phenolphthalein. So this has potassium iodide and water in it. And then I'm going to put this phenolphthalein in there. So you guys can see that this is a little bit milky, but it's not colored at all, right? So what this is actually an indicator, and it tells me if hydroxide or hydrogen ions are present. So it's going to turn pink if we get hydroxide ions. So do you guys remember acids versus bases? Yeah. So acids have hydrogen H plus and bases are OH minus, hydroxide ions. Okay, so when water decomposes, it turns into hydrogen ions and hydroxide ions. And if one of those is present, the phenolphthalein will turn pink. Okay, so what I'm going to do, I grabbed 2 batteries because I'm not actually 100% sure which one works. I'm going to put this carbon rod in this end here, and this other carbon rod in this end of the potassium iodide. I'm going to hook this red one up to the negative side of the battery and the black one up to the positive side of the battery. And then if you guys want to come in just a little bit closer, I hope this battery works. We should start to see something in a second. What color is iodine? Has anybody seen iodine? Red. It's like like red brown. Yeah. What are we waiting for? Great question. Okay, other battery. I need to really test these out and see which ones work. Okay, this one's gonna work. Okay. So it's happening. It's really slow. Do you guys see a color starting to form? Yeah, I'll back up the way. No. You don't? Get a little closer.
I'm kind of blind to that though. So.
Oh wait, yeah, I do. It's like yellow. Yellow right there.
Yeah.
Oh, I just see clear, bro.
Oh yeah.
So on the positive side there, you guys can see a slight brownish red starting to form. So that's iodine. So that side, the positive side, is actually decomposing potassium iodide into potassium, which doesn't have a color in water, and iodine, which is brown in water. And then is there anything happening on the other side?
No. Looks purple.
Oh, okay. Purple.
I mean, that could just be the reflection.
Oh wait, yeah. Kind of purple.
Yeah. And any bubbles or anything? It's like a leading question. We should start to see some little bubbles forming on the outside of this one. If we look closely, there's some little bubbles. So what's happening on this side is water. The water that's in the solution is actually decomposing into hydrogen, which is what the bubbles are, and hydroxide, which is why now we can see pink on that side, because the phenolphthalein turns pink when it's in the presence of a base or a hydroxide ion.
Are you doing this time?
Yeah, okay, look a little closer in there, guys. You can see some bubbles now. They're really little.
Go have a look. No, not me. I'm sitting. Sitting. Why?
Cool. Okay, I'm gonna leave this set up and we'll just let it run to kind of see how intense these colors get, if we get more bubbles. But yeah, this is the process of electrolysis, so the breaking down of compounds into their elements.
So what's in the tube?
Potassium.